When users create new parts, they nearly always start by creating an initial sketch profile. However, it's often hard to gauge the scale of the sketch while laying it out. SolidWorks 2014 completely eliminates this with an enhancement that you never even see happen. When placing the first dimension in a sketch, SolidWorks automatically scales the entire sketch to preserve the size and position of all the entities within the sketch. Furthermore, SolidWorks has also maintained our view and zoom perspective, keeping everything intact, meaning we can get right to applying the rest of the dimensions to the sketch. When selecting multiple entities using the traditional box selection method in SolidWorks, sometimes extra entities are selected and need to be deselected, or the selection needs to be performed on an entity-by-entity basis. The new lasso selection tool, found by simply right mouse clicking, allows you to select objects similar to photo editing software by simply dragging around those items you wish to select. This method still preserves the SolidWorks left to right selection where only those entities completely selected are chosen, or the right to left method of selecting any entity which has been crossed over. This makes it fast and easy to select the right entities at the right time, for instance, adding relationships as in the case of these two circles. And it's easy to toggle between the two anywhere in the software through the right mouse button menu. In this scenario, we're trying to lay out a belt drive system, and the length of the belt would be the preferred method of defining the position of the remaining geometry. However, we did not originally create this sketch using blocks and path sketches. You can now, however, easily add a path length dimension on the fly with the new path length dimension tool. Simply select those entities which you would like to include in the path, and SolidWorks automatically converts them to a path for you. Then simply enter the appropriate dimension value and the rest of the geometry is constrained. When utilizing an image or picture as the starting point for a new design, it's crucial that the scale of the image is to scale. However, digital media is often provided with no real presence of scale. Sometimes, however, a known dimension is available or sketched onto the image for reference. SolidWorks 2014's new Sketch Image Scale tool now makes it simple to get the scale right in three-dimensional space. Simply drag one end of the scale to a known position in the image, and then the other end to another known position. As soon as you release the cursor, you'll be asked for this known value, in this case 6.5 inches. As soon as the value is entered, the image is scaled using this reference value. Additionally, you can use the scale for placement within the document to control the position of the image, as well as any adjustments that might need to be made to the angle of the image. When creating consumer products, oftentimes they are created using some of the more advanced sketching tools found inside SolidWorks. This board design has several areas where it could use some improvements using several new enhancements found in SolidWorks 2014. Let's start by changing the path of the sweep used for the strengthening rib found on the bottom side. This sketch currently uses simple fillets and might benefit from some conic fillets instead. Now, when you add a conic to a sketch, there's an option to automatically add tangency relationships to adjacent sketch geometry. This removes several steps where previously you would have had to select the conic and the adjacent entity and manually apply the tangency. This will save lots of time if you are adding conics, especially in multiple places. Now, all that's required is to add the appropriate dimensions to the sketch. This includes the row values for the conics themselves, as well as the length of the adjacent lines. And as you can see, the sketch is now fully defined without the need to manually add any sketch relationships to the conics. We'll do that to the sketch profile used in the same feature. Like before, we'll remove the existing entity, and again, adding the conic is easy, as the sketch relationships are added automatically. And again, all that's needed is to add the row value, and in this case, we'll move the sketch geometry by simply snapping it into place. Now, when we close this sketch, we can see that all of the geometry in this part has updated with a new, more desirable conics in place of the previous simple geometry. This is just another example of the power of parametric modeling, of which you'll definitely see some more. Another entity used a lot in consumer products is the powerful spline tool. When we take a look at this sketch, which defines the overall length and shape of the board, we can see that it's well defined already, with the exception of the overall length. In some scenarios, such as wanting to define the amount of material used, such as how much carbon fiber is needed and the overall length of this design, specifying the length of the spline would be desirable. And that's exactly what SolidWorks 2014 allows you to do now. This provides more control over splines and is useful in other areas as well, such as cable and tube lengths. Finally, while we're talking about splines, sometimes, especially for new users, they can be intimidating trying to get all the geometry just right. Controlling the inflection and maintaining a smooth profile require proper definition of spline points, such as this spline here. SolidWorks 2014 introduces a completely new spline tool that removes all of these concerns, called the style spline. Instead of individual spline points, which need to have the curvature and magnitude controlled, they are simply placed with construction lines. These lines can then be further defined using simple and familiar sketch relationships and dimensions all users are familiar with. As all the required relationships and dimensions are added, it becomes fully defined quite easily also, letting us know it will be fully controlled by any upstream design changes. If we take a look at the curvature of this style spline, we can see without any extra effort, every bend is smooth with minimal inflection. Finally, we would like to update this feature and all downstream features to utilize this new style spline as opposed to the previous spline. Replace Sketch Entity now makes this possible. All that's needed is to select the entity which you would like to replace and then the entity to replace it with. There's even the choice to keep the previous geometry as a construction entity or delete it completely. Now, when the sketch is closed, not only does this feature update, all downstream dependent features also now reference this new spline and update with zero effort. Swept flanges introduced in SolidWorks 2012 are powerful sheet metal design tools. However, in certain circumstances in previous versions of SolidWorks, cylindrical and conical sweeps could unfold about the wrong edge or path direction. Now in SolidWorks 2014, there's a new option within the swept flange feature to provide precise control over which edge to anchor the part from when unfolding. This gives you the desired flat pattern for cylindrical and conical swept flanges. A completely new sheet metal feature highly requested by users is the new sheet metal gusset. Like weldment gussets, there's a variety of options to control the geometry, such as an intended depth or specific dimensions for the lengths of the sides. You can define if it has a flat or full round top, as well as controlling the overall width of the gusset. Likewise, you can specify the internal radii and SolidWorks will automatically offset the material thickness for the outside fillets. Once defined, the feature accurately represents the desired gusset. Also subtle but new is SolidWorks' more comprehensive ability to remember property manager values when creating additional features. So when a second gusset is added, as long as we want the values to be identical, we simply need to select the appropriate faces and press OK. And an identical feature is created. Manufacturing sheet metal components often means precise control over corner reliefs. SolidWorks 2014 completely redefines what it means to create these by allowing you to now define them in the context of the formed or folded part. Similar to many other SolidWorks features, selection is easy with a Select All button which quickly gathers every corner on the part and allows you to simply place a relief type globally at each instance. Alternatively, you can choose to control each corner specifically by simply selecting the selection bubble at each corner. There's 5 unique corner reliefs to choose from too, which include rectangular, circular, tear, oblong and constant width, ensuring you're able to design and visualize the part the way it was intended to be manufactured. Another scenario that greatly affects manufacturability is the use of lofted bends, another unique and powerful sheet metal design tool. And though SolidWorks has always enabled us to create these using formed methods, SolidWorks 2014 now provides an option to show this feature in a bent or transitional state. Like corner reliefs, there are several choices here in defining how the bends are defined, including chord tolerance, number of bends, segment length, and segment angle. In this case, number of bends is preferred. Once specified, again, like corner relief, you have the choice to explicitly change each bend region, for instance, defining the second instance by bend angle. And of course, like all sheet metal parts and features in SolidWorks, it's completely unfoldable, providing the vital manufacturing information to create the part. Before looking at the many enhancements for weldments and parts, it's important to take a look at one of the many subtle enhancements in SolidWorks 2014. When working with thin parts, users would often see edges from coincident components bleed through the surfaces of thin parts, which you can still see when we zoom and rotate. In SolidWorks 2014, though, these now go away when you stop rotating or zooming on the model, sure to make for much more stunning screen captures and a more pleasant view to the user. When working with weldments, managing the many profiles provided by SolidWorks and those created by each user can oftentimes be overwhelming. In this case, we've downloaded the SolidWorks ANSI profiles, and within the rectangle profiles, there are 233 separate files to manage alone. What happens when you want to add your own custom properties or modify these files? Oftentimes, this needs to be done on a file-by-file basis. SolidWorks has completely streamlined this entire process with the introduction of configurable weldment profiles, perfect for managing all of your unique sizes. Now, instead of subfolders for type, there are simply single files for each type of profile. If we open one of these files, we can see the file is populated with a vast amount of profiles to choose, all from within a single file. To further benefit from this, all of these profiles can be created and maintained using powerful design tables to rapidly create all the different sizes. This is done leveraging simple Microsoft Excel concatenation and speeds up the entire process of creation drastically. Back in the weldment, we can see that the property manager has not changed at all, though now we simply choose a file instead of a type folder. These are noted by the configuration suffix at the end of the file name. From there, configurations work much in the same way, in this case selecting a smaller profile to switch to. And because all of these profiles are created not only from the same part, but the exact same sketch, there's no missing references created when switching either. Configurations for weldment profiles makes the whole process a lot easier, as you can easily include custom properties all with a design table shown before too. While on the topic of configurations, let's create another version of this table, specifically a square version as opposed to this rectangular one. An easy way to change this design would be to simply enter the same value for the depth of the table. But a more powerful way to do this would be to apply an equation. However, equations in the past have been consistent across all configurations of a file. Now in SolidWorks 2014, however, equations can now be specified as configuration specific. We can see that the dimension has the drive-by equation symbol next to it, and if we go to the equation manager, we can see this equation listed. However, when we switch configurations, the model returns to its previous size and the equation disappears, as it's only solving in the specified configurations. This is sure to add more flexibility and powerful control over your designs. When adding holes for fasteners, sometimes a slot is a better choice, as it allows for more tolerance in mounting conditions. The Hole Wizard in SolidWorks 2014 now supports slots. Specifically, it supports three types: slots, countersunk slots, and counterbored slots. When this hole is changed to its slot counterpart, there are options to control the slot just like a hole. More control is available in the placement sketch, where you can define the orientation of the slot using the provided construction line. You can add dimensions to this line, specifying the angle, or simply add a relationship. Additionally, you can control the slot length here, or when returning to the Hole Type tab, it can be entered into the unique field specific to slots. Some of the simplest features are the most enjoyed by SolidWorks users. When creating an extrusion in SolidWorks, users who want to cut in both directions can now, instead of choosing through all in two separate directions, they can simply choose through all in both directions, a simple yet convenient time saver. When deleting features in SolidWorks, you now no longer need to worry about child or dependent features being deleted, as you can now deselect the option to delete child features. All of the child features are preserved, but with warnings as some of their references are now missing because we've deleted them. Let's replace the plane we just deleted with a new one. When you create reference planes in SolidWorks, you can now control the direction of the normal condition, giving you more control and ensuring that any downstream changes affected by it are in the proper position and orientation. Now, to redefine the missing references we removed previously is easy as selecting the new plane. And because we set the normal direction, nothing has changed or presented a warning. While on the topic of reference features, SolidWorks 2014 has provided more conditions when creating reference points. Specifically, when creating on-point conditions, reference points can now be placed on sketch points and the endpoints of lines. Also, intersection now supports the virtual intersection of an axis on a surface, axis on a plane, and the intersection of an axis and an axis, all without the need for the geometry to physically intersect each other. Three-dimensional design allows you to extract vast amounts of knowledge about a model using mass properties. Now, interpreting these values is easier with support for non-mechanical or more traditional volumetric properties. You can now use volumes such as liters, pints, gallons, and more. This is useful when utilizing these values in custom properties or cut list properties. Finally, cut list properties are often critical for the manufacture and detail of the individual pieces, and it's important to preserve this information. Now, when saving a body from a weldment with cut list properties, you can choose to propagate this information over to the new part. You can choose whether to preserve this information in the new file's own cut list property information, or move the data to the custom properties for the file. Furthermore, when you look at the properties, it's clear that this information is derived from the cut list item. In fact, should the original design change, this information will update accordingly as it's linked to the parent file.
In consumer product design and other applications where aesthetics are important, constant and variable radius fillets have limited use due to the sharp change in curvature. Curvature continuous fillets produce smooth results but are limited to a single constant radius. Now the fillet feature in SolidWorks 2014 gives you even more control to define a new type of shape, a constant or variable radius conic fillet. A bottle is a typical example of where the shape of an edge is blended to make it look good. Let's delete this fillet and add a new conic fillet to this top edge. Straight away you will notice that the user interface has been enhanced to give you extra control. A new pull down lets you determine the shape of the fillet profile as either a standard circular fillet, a conic controlled by row value, which as I'm sure you'll recall is the angle of a plane intersecting a cone, or by conic radius, which is the minimum radius of curvature of the conic. Just like the conic sketch entity, if you adjust row to be a small value, the shape becomes flatter, almost like a chamfer. And a higher value makes the fillet sharper, so it gives you lots of options to explore. Setting row to be 0.4142 gives you the same shape as a circular fillet. Perhaps more useful is the conic radius. Setting the minimum radius of curvature to be the same as the fillet radius also gives you a circular fillet. but now you can control the shape of the fillet by exact known sizes. Adding a large radius flattens the fillet, adding a small radius sharpens it. What makes this feature so powerful is that you can combine it with a variable radius fillet, so you can define the fillet radius and the conic radius as any number of points along an edge. Setting all points to be equal gives you a starting point of a constant radius circular fillet, and from there you can start to make your adjustments. Changing this centre point to be 15 with a conic radius of 2 gives you a nice blended shape while keeping the side edges constant. Likewise, you can change the fillet shape to get a sharper profile around the edge of the bottom face. Conic fillets can also be created using face fillets, which are especially useful if you need to fillet surfaces with no common edge. The user interface has changed here too. The width of the fillet can be controlled by setting this value to radial, which creates a regular fillet, or to chord width, which was previously called constant width, but now also shows a graphic to describe what it's doing more clearly. Then you have the option for curvature continuous as before, so just a minor change to the interface there. However, switching back to radial gives you the extra options for conic row and conic radius, so you can create dramatic or subtle fillets with ease. To complete the model, adding some conic fillets to the neck of the bottle creates some interesting effects. Using either an edge or face-to-face conic fillet, the end result is similar to adding draft or taper to surrounding faces. With the new conic fillet feature, SolidWorks 2014 provides a wider variety of simple point-and-click blending options that give you the control you need over your desired shape, in addition to the more powerful boundary surface and fill surface features.
Before reviewing the many enhancements made to the drawings environment in SolidWorks 2014, there's one drawings-related enhancement that's been made to both parts and assemblies. To facilitate product manufacturing information, otherwise known as PMI data or paperless, SolidWorks has added a new type of annotation plane in both parts and assemblies. The notes area is an annotation plane that supports the placement of things such as the title block table. But the best part is it's static and doesn't rotate with the model. This annotation plane also now supports all table types, not just the general table or bill of materials, as was the case in previous releases. Back in the drawing, SolidWorks' view palette has always been a place to easily find and place standard and custom views in the model. Now, in SolidWorks 2014, SolidWorks retains any placed views and instead shows which views are already on a drawing with a simple icon, making it easy to pick out any missing views. But more importantly, it allows you to go back at any time and add additional instances of a view that's already been placed. Though in this case, there's no need for two bottom views. A decent amount of work has gone into this drawing. However, all the work was supposed to, in fact, be done on the assembly in which this part exists. Replacing the models of view references is now an easy button pick. Simply choose the model to reference. This can even be a different document type completely, such as the parent assembly. Then specify which view should be replaced, or simply choose the All Views option if that's desired. Every view selected will then be updated with a new model, and if the previous model was derived from the same part, or in the case of an assembly contains the part, anything that already has been created on the drawing will be preserved. This is great for those cases where you started a drawing with the wrong file or want to create a new drawing based on a similar file. With a new model, we're required to make some adjustments to the section view on the bottom view to show some of the hardware in the assembly. Editing section lines created using the powerful Section View Assist tool introduced in SolidWorks 2013 now fully supports all the tools used to create it, keeping you in a familiar, easy-to-use tool without ever having to edit the underlying sketch. Now that the section has been updated through this stack of hardware, it would make sense to add some stacked balloons. If you've ever created stacked balloons and accidentally selected the wrong components or selected them in the wrong order, you're sure to love the new ability to reattach stacked balloons to new components. With a simple right mouse button command, you can specify a new part and the stacked balloons update to the new item number or any other property included in the balloon. This means you no longer have to delete stacked balloons and replace them to get them in the right order. While everything in the section view looks correct, as it should be, there's an enhancement here to point out that's new in SolidWorks 2014. This laptop cover part is in fact a surface model, not a solid body. Previously a limitation, SolidWorks section views now fully support creating section views of surface bodies, eliminating any workarounds required in the past. When adding dimensions, sometimes the virtual intersection of geometry is oftentimes the ideal location to dimension from. Doing this in the past required first creating a virtual sharp point, and then adding the dimension after it had been placed. Now, however, you can find the intersection of two entities on the fly while creating the dimension, eliminating this extra workflow to get the dimension you want. SolidWorks is still creating the virtual sharp behind the scenes, it's just doing it in a much more streamlined workflow. We can do this for both ends of the dimension too, and then easily place it with a dimension placement tool. Users of traditional 2D drafting tools love control, and SolidWorks 2014 provides more control for dimensions with the ability to explicitly control the leader and the extension line separately, allowing for both to have unique line styles as well as color and weight. There's even more control when it comes to dimensions where the dimension is above the leader, such as an ISO standard dimension. When you enable dual dimensions, you now have the ability to split the dual dimension so that the primary units are above the leader and the secondary are below. You can also control text that you would like to be above the leader line and a new separate field for text below the leader line. Other enhancements to annotations can be seen when working with notes. This note has some unique characteristics in that it's linked to the view in which it resides. When moving annotations from one view to another, in the past you would have to cut and paste the note, oftentimes leading to the annotation moving on the drawing. Now, with the new attachment option, you can simply specify a new view, or even the sheet if that would be desired, and the note is changed with zero adjustment to its placement. Also, this note has been created in all lowercase text. Reading the text, however, it should be in all uppercase, as is the desired standard for most organizations. Instead of recreating the note, however, SolidWorks has drastically simplified this problem with the all uppercase checkbox, which when checked changes the case of all the text. However, you can specify an exclusion list to avoid automatically setting this in the case of things such as unit callouts, such as MM or IN. A detail view will provide us with an opportunity to look at the next set of enhancements in closer detail. When detail views are created, the note for the view is provided automatically. These notes come with intelligence built into them. However, in the past, if you deleted this text, the intelligence would be lost. In fact, if you deleted all the text, how would you get it back? Now with view tags, this information can be propagated automatically using special tags which reference the drafting standard in use. For instance, if you look at the section view portion of the document settings, you can see where all this information is derived from. Tags allow you to point to these specific fields, ensuring your drawing always adheres to company standards. With slots being a new feature in the whole wizard, it's important they're fully supported everywhere in the software. SolidWorks 2014 carries on support for slots in drawings, first with center mark support. Just like holes, they can be created and populate patterns automatically. Likewise, we could have enabled the option to automatically place these in the drawing as well. Also for slots is support for hole callouts. Using the same tool and technology behind hole callouts, it keeps things consistent, looking at the underlying geometry to gather its information. Of course, we need to further dimension these slots, including their location, and the angle is one of them. Now, when placing angular dimensions, it's easier than ever to make everything line up just right with new soft snaps for angular dimensions. There's no more guesswork hoping you got it just right. But dimensioning every angle this way would overcrowd the view. Using the new Angular Running Dimension tool, we can dimension the angle of all of these features much more efficiently, and it's much clearer to understand. Just like ordinate dimensions, you place the first dimension and then subsequent locations are defined. Also, like ordinate dimensions, you can always go back and add further callouts to the same series. There's also a variety of choices to display the angular running dimensions, such as chain, bidirectional, and control over the extension lines. This ensures that they look just the way you want them to. Datum features have also been improved in SolidWorks 2014 to make them easier to place. They now support placement on points instead of just edges or existing dimensions, meaning there's no fuss to get them where you need them. And while not a proper geometric dimension, let's add a simple note to reference that data. Well, in the Note tool, or any tool that utilizes symbols, you'll notice a completely refreshed symbol library that's much easier to navigate. Sorted by logical areas, symbols are easier to find. And the new library even supports your favorites as well, making them easy to return to. You might also notice that now selecting on annotations now highlights any geometry they are attached to, making it easier to understand where a note or dimension has been attached. Let's add another sheet to place a bill of materials. You might notice when doing so, we're not presented with a dialog box asking us to specify a sheet format for this new sheet. That's because you can now predefine a sheet format to use for any subsequent sheets added after the first, though you can also add them the old way as well if you prefer that control. Now, when we add the bill of materials for this assembly, you might notice that everything is already in numerical order on the table. That's because SolidWorks 2014 now allows you to save any sorting methodology you choose in the bill of material template, saving the extra step needed when first placing a BOM table. There's also now support for unique toolbox properties in the bill of materials as well. These include things such as the standard or the specification of the hardware, allowing you to extract specific information from your hardware for downstream applications. This bill of material looks and fits well on this drawing sheet, but what if it were to get larger and extend off the sheet? In the past, we could, after the bill of materials has updated, manually split the table anywhere we chose. Now, however, in SolidWorks 2014, you can specify a row count in which to split the bill of materials. Even better, you can specify that SolidWorks always preserves this, even as the design changes, and control how the split table will be placed. When we add several new components to the assembly, referenced in the drawing, in the past we would have to have made these changes reactively. However, in SolidWorks 2014, when we return to the drawing, we can see that by previously setting the row count to split at, we've proactively avoided unnecessary cleanup, and the drawing looks great as well.
SolidWorks Enterprise PDM 2014 continues to add new and exciting functionality to streamline your design process and ensure that you're always working with the most up-to-date information. First, new options have been added for users and groups to keep local cache up to date. These options allow you to clear the cache on logout and refresh the cache on login. These settings are folder specific and work recursively into subfolders. This is important for users who have certain templates or library items that need to always be at the latest revision, or for administrators who need to make sure that users who are not attached to the network do not have sensitive files on their computer. A new checkbox has been added to the reference node in the settings dialog called Enable the Get Version command in SolidWorks Add-in. This allows users who choose the setting to always work with latest the ability to do a get version when working in SolidWorks. This is important because they want to ensure that any files that are checked out are referencing the latest versions, but want to have get access to older versions for reference or comparison. Let's log into the Vault. Notice that upon login, Enterprise PDM is updating the cache with the latest versions of the files that are in the folders that we selected, keeping everything up to date for me. Let's take a look at the Contains tab for this assembly. Now in Enterprise PDM 2014, we can customize the display of columns in the Contains tab, the Where Used tab, Copy Tree, and the Checkout and Check-in dialogues. Let's add the Description column to the Contains tab and move it toward the left. This is important, especially when people use numbers for their file naming convention. They'll now have access to more descriptive information. You also have the ability to collapse and uncollapse components in the tree, as well as a tool to show top level or show all levels in the assembly. Now this assembly is already open in SolidWorks, but you can see in the Checkout dialog we have the same ability to add columns and access to expand and collapse the assembly. But new is the ability to show reference selection controls, or otherwise known as parent node checkboxes. These allow easy access to checkout or get a parent and all of its children. We now have the ability to easily see warnings that may be presented. If there are no warnings, these don't show up. They even traverse into collapsed subassemblies to show warnings as well. With very large assemblies, these tools can be very helpful to find any warnings that may exist. Since we have this assembly already open in SolidWorks, we see lots of warnings. So let's take a look at some of the new things in the SolidWorks add-in. First, the first thing you may notice in the task pane is a new column for reference version. This column lets us know what version of the file was referenced in an assembly when it was checked in. As I dig down into this subassembly, you can see that I'm working with the latest version of this file, but when the assembly was originally checked in, this file was at version 1. The information in the reference version column gives me this feedback. The child quick info also points me to this older reference version. Since this is referencing an older version, I may want to use the get command to see the older version of the file. As expected, we get warnings that the file is not using the latest, and with the child quick info, I get the indication that I'm using an older file. And this warning goes all the way up the tree, no matter how deep in the structure it is. In SolidWorks 2014, we've done a lot of things with costing to streamline the workflows to allow you to cost your parts faster and with less setup. One area of focus was in the area of volume costing. Volume costing was added in SolidWorks 2013, but still required that the costing templates contained information about materials and tooling. Some users don't want to have to deal with the templates at all, and others want to be able to easily get costs for volumes without defining tooling information. Let's see how it works. If we run costing on this part, you'll notice that there are some features that have no cost assigned. This could occur because the material and tooling combination was not properly set up in the costing template to properly machine the feature. Well, with SolidWorks 2014, we can now access costing options directly from the costing task pane. The costing options are broken down into 3 areas: sheet metal, machining, and finishing. Let's take a look at the machining options. For each part, we can now control whether SolidWorks Costing uses the standard material processing method or recognizes all material removed as a volume. When standard recognition is selected, we have the option to process slots as slot features or as volume features. The other option is to recognize all material removed as a volume. With this option, we can choose how to calculate volume features, either with a default machining operation, which requires template setup, or with a cost per volume removed method. Cost per volume removed does not use the template information. It's simply calculated as a currency value per volume. These values can be determined from similar parts that you may have machined previously and can be altered depending on part complexity. When we select this method, the part is recosted, and you'll notice that there are no longer any features in the No Cost Assigned folder. You may also notice that there are no setup costs. This is because the volume method includes the entire cost in the cost per volume value. So this is a real quick method of getting cost information for your part, which is especially useful when you don't have all the materials and tooling defined in your templates. Let's set this part back to the standard feature recognition method and look at the setup information. This area has been reorganized with folders containing setup information for each machine, custom setups, and a new type that accounts for the loading and unloading of each part. This is controlled in the template, where two new columns have been added to the machine area. A column has been added to account for the time it takes to load and unload each part being processed, and the operation setup time column has been moved here from the general area, which allows you to control the machine setup cost for each machine separately. This column also exists for the cut operations as well. Another enhancement is that you can now save a copy of the template as a limited access copy. The information in this template will not be able to be accessed by the user. They can use it to cost their part, but cannot see the cost data in the template. This is important for machine shops who have customers who request a lot of quotes. They can give them the limited access copy to do their own costing, but not have to reveal all their detailed cost numbers. Notice that when I switch to a limited access template, I cannot launch the editor. Let's take a look at some enhancements for sheet metal costing. First, there is now an option to include a percentage of scrap in your cost calculation, which can be important when nesting many parts together. For parts like this, where there are features that are machined into the part, you may want to get accurate costs to machine the countersink and tapped holes as opposed to calculating them as cut paths. For this, we now allow you to use the machining template to calculate the cost of sheet metal parts. We also provide an option to allow you to override the feature processing for bends, hems, and library features. This can be important to get quick cost quotes when you don't have complete information for those features and the corresponding material thicknesses in your template. Looking at the costing manager, we can see that the bends are now identified using the default cost that we entered in the override. You can also see that the tapped and countersunk holes are now being drilled and not using cut paths. The clearance holes can easily be changed from cut paths to drilled holes. And the slot on the backside is being identified under the mill operations. Let's take a look at another part. First, you can see that there's no material applied. Now, when you choose the material, you have the option to set the material in the part as well. This allows you to experiment with the materials and then set it to the part when it's finished. Often you have a part like this to be costed, and you may not have the proper tooling set up in your template, so you get items in the No Cost Assigned folder. In reality, this should be a plate part, and therefore your profiles will be costed using a cut path. But sometimes you want to control whether the features are costed as cut paths or as machine features. Now, in SolidWorks 2014, you have this option. Let's select all these holes and change them to drill features. Notice that two holes do not have cost assigned, and this is because there's no drill of that size, so they can easily be set back to cut paths. With all this flexibility, you'll get more accurate quotes with less effort.
SolidWorks Electrical Schematic has some great new enhancements to help electrical engineers be more productive. When working or collaborating on multiple projects, it can sometimes be difficult to find a certain project. New filter options in the Project Manager allows you to quickly search between all of your projects using the project name, description, or creation modification date to find the one you want to work on. Electrical systems often require multiple pages of diagrams and schematics. The single-line diagram is a unique and innovative tool that allows engineers or project managers to have a general understanding of the complexity of the project. Unfortunately, it generally requires users to switch back and forth between the two diagrams when working on a project. In 2014, you can simply copy and paste the single-line diagram directly in the multi-line schematic, simplifying the workflow while still being able to access all the information that make a single-line diagram so useful. Dealing with multiple locations can be a challenge, and manually having to modify several symbols to define a new location can be time-consuming. The location outline is a great way to define locations on your schematic and makes it easy to relocate components. Users have always had the ability to define new components to customize a library of symbols. SolidWorks Electrical Schematic 2014 includes a new type of symbol called passive symbols that let you define components without electrical characteristics, like this twisted ground shield. This symbol is now stored in the library and is always available to be inserted whenever you need it. With electrical systems that keeps growing both in number of electrical parts and in complexity, finding the part or symbol you need to modify can be tricky. The search tool is great for locating components easily. You can search using a mark number and then quickly find all the different representations of the part. Select any of them and a nice preview provides some context and information about where the part is used. You can also access the search tool from the component list and look for an electrical part using its description, mark, location, class, or any combination of its properties. Once you find the correct one, you can go directly to the right representation in a click of a button. This disconnector is properly connected, but in some cases, one might want to hide some components or simply add space for future annotation. The new Drawing Wipeout tool allows you to rapidly create a rectangle or any complex shape to hide this component. Some circuits are still missing in this diagram. SolidWorks Electrical has always had multiple ways to quickly copy and reuse existing parts of your schematic. However, when reusing some existing circuits, you previously had no control over which components needed to use the same mark or be recreated. With the new Paste Special, you have complete control over which mark to create or to reuse. In this case, we are creating a completely new terminal strip, but it would have been just as easy to keep using the existing one. When designing this part of the circuit, we forgot to add the wire numbers. In SolidWorks Electrical 2014, wire labels and equipotential labels are just a click away. Simply select the wires and use the contextual menu to quickly and effortlessly add them to this diagram. And like any other element in SolidWorks Electrical Schematic, these labels can be completely customized through the project setting options. The same holds true for cross-reference symbols. The control circuit diagram shows cross-reference symbols for the contactors. These are perfect to quickly determine if all the contacts on a specific contactor are used. You can now edit the cross-references to customize them as well and eventually change the colors you have used. Finally, before switching to SolidWorks to design your panel in 3D, you can visit the SolidWorks Electrical portal to download the 3D model of your electrical components, which saves you the trouble of having to manually design each of them. New catalogs and recently updated catalogs of parts are highlighted. You can also use the classification on the left to navigate through the website or the powerful search engine to find the part you need. Detailed information such as a part number, manufacturer, number of contact, or the maximum current allowed are available in addition to the part 3D picture to help you make sure you are choosing the correct component. Then, simply download each item or hide them to your basket to download them all at once. Thanks to several new enhancements, SolidWorks Electrical Schematic allows you to define your electrical system faster no matter what your everyday design challenges are. SolidWorks Electrical Schematic also offers some great new calculation and reporting tools. The power circuit in this electrical system features a couple of three-phase motors that are connected to the electrical panel and the terminal strip using 4 core cables. Let's open the Cable Manager to add some of them to our project. After choosing some cables from the vast library of cables available in SolidWorks Electrical Schematics, we can manually modify some properties. The length, for example, is automatically calculated when wiring your system in SolidWorks, but can be overwritten. In addition, SolidWorks Electrical 2014 also lets you define the band radius and the voltage drop. These properties are provided by the manufacturer, but can be entered manually if they are missing. Then, you can define the applied voltage, full load current, and in-rush factor. These values directly depend on the load connected to the electrical panel, and in this case the motor's properties. With the cables properly added to our project, we can quickly replace the wires that are currently used between the terminal strip and this motor by simply selecting them and using the contextual menu. Then, it's just a matter of selecting the cores of our W1 cable and associating them. The new Design Rules Check tool lets electrical engineers investigate the systems for design errors such as symbol without manufacturer parts, non-connected wires, or equipotential conflicts. Using the properties we just typed in, you can instantly know the voltage drop for all the cables used in the schematic. There are a cable per row and the location, length, and all the other properties that were entered previously are displayed for added clarity. The voltage drop in volt and percentage are automatically calculated along with the peak current and the power loss. Additional templates can be used just as easily to check for unused cables, empty terminal strips, or wires without marks. The Design Rules Manager is simply an amazing tool to effortlessly find and eliminate costly mistakes or inconsistencies and to improve your products. Finally, sharing key information between different departments of an organization is made easier with publish-to e-drawings. The schematic diagrams, reports, and all other documents of your project can be grouped into a single e-drawings file using the same familiar export interface. You can quickly communicate with your peers inside and outside your organization and access all of the critical project information using the multi-platform desktop and mobile applications. Thanks to several new enhancements, SolidWorks Electrical Schematic allows you to design your electrical systems faster and better no matter what your everyday design challenges are. SolidWorks Electrical 2014 introduces many new enhancements to streamline tedious or time-consuming tasks and speed up the conception of electrical systems in 3D. SolidWorks Electrical has many powerful and unique capabilities. You can easily and almost automatically route all the wires and cables in your assemblies, thus automating what used to be a long and repetitive process. However, you can now, in SolidWorks 2014, wire the entire panel in just a couple of seconds thanks to a new calculation method that takes advantages of multi-core processors to cut down the time needed by 5 to 8 times. This allows you to get your project done faster and helps reduce the time spent by mechanical or electrical engineer creating design variation or optimizing their electrical system. SolidWorks Electrical 2014 also enables you to create 3D harnesses and accurate and up-to-date engineering drawings from start to finish with minimum effort. With the harness already created in SolidWorks Electrical Schematic, all is left to do is insert the connectors, which can now be assembly connectors with pins, seal, backing cover, or mounting screws, for example, and heat root harnesses. After selecting the right one, the harness is now properly routed, with all the connectors automatically added to the correct harness subassembly. All the individual wires are represented using the color and size defined in the schematic and connected to the appropriate terminals for each single connector. Clips and covering can also be added and are now perfectly supported when flattening the harness. once the clip is added to the harness, you can reroute part of the wires or cable through the cable holder using its dedicated command. The covering, on the other hand, is applied just as easily by selecting the proper segments. Then, like any other harness designed inside SolidWorks, and without additional steps or workaround, you can directly create a flattened representation and generate the relevant drawings. In fact, in just a couple of clicks, you can go from a multi-line diagram in SolidWorks electrical schematic to a complete drawing with connector tables, a bill of materials, and a circuit summary. Simply select the method, annotation, or manufacturer and modify, if necessary, the drawings option or items you want displayed. You can edit the flatten route to make some changes, spread more the connectors, and get exactly the result you're looking for using the different tools available. The modifications are instantly propagated. The drawing includes all the electrical tables, a complete circuit summary, and new in SolidWorks 2014, the pins are colored when displaying the connector blocks for added clarity, and the clip and covering are correctly flattened. The pin colors are also listed in the connector tables. SolidWorks Electrical 2014 helps you integrate electrical rodded systems faster with significant performance improvements and new functionalities that simplify your workflows and reduce the time it takes to complete your design.
SolidWorks 2014 introduces many powerful new features and time-saving shortcuts that are sure to delight every user. First, rotations are now supported in exploded views. Adding these rotations make explode animations much more realistic. Simply choose the components to explode and you'll notice that there are now rotation rings along with the linear manipulator triad. There's also an option to rotate each component about its own origin as opposed to rotating them as a group. Drag and drop the manipulator to define the linear explode, and then drag the ring to define its rotation. It's that simple. To define the rotation of the cylinder, we can now drag the manipulator without having to hold the Alt key to define the rotation axis, and then drag the cylinder out of position. One of the best ways to communicate assembly steps is to animate the explode or collapse, and with the new rotational explode steps, this communication gets even clearer. Identifying and changing configurations of components in an assembly is now much easier as they are now accessible right from the context toolbar. They're even accessible when selecting subassemblies. Changing configurations can now be done directly without having to access the Component Properties dialog. These configurations can be accessed from the graphics area or from the Feature Manager, and now assemblies can be made flexible directly from the context toolbar as well without having to access the dialog. The way that flexible subassemblies solve has been reworked so that assemblies, such as this, that contain multiple instances of the same flexible subassembly will now behave in a more predictable manner. Enhancements were also made in regard to mirroring components. SolidWorks 2014 now supports many more mate types when mirroring parts and subassemblies. Mates such as cam, hinge, linear coupler, path, symmetric, universal joint, and width mates are now supported. These mates are added to the mirrored subassembly or recreated in the main assembly if the mirror component is dissolved, thus saving time having to reassemble components. In SolidWorks 2013, when mirroring components, the opposite hand version was positioned along the center of mass. Now there's an additional option to choose the bounding box for the mirror position. Let's take a look at this scissors assembly. Currently it's symmetric, but if I unsuppress an extra component, the subassembly becomes unbalanced, and you can see this when I display the center of mass. Notice that the subassembly was mirrored as specified by the center of mass, and you can see that the centers of mass line up correctly. But this isn't what I want. I really want them to be mirrored about the center of the scissors assembly, not the center of mass. With the new bounding box option in the Mirror Components tool, I can now account for this and get the results I desire. When working with large assemblies, it may be desirable to remove small components. In earlier versions, we could use the Advanced Selection tool to select by volume or mass, but this tool was not really easy to use, much less find. Now in SolidWorks 2014, a new Select by Size tool is available and works as easy as dragging a slider to select components as a percentage of the assembly size. Once selected, I can act on them by hiding them or suppressing them just like any other selection. Many users express concern that when they check the option Scroll Selected Item into View, that the Feature Manager never remembered where it was. With SolidWorks 2014, when you select an item in the graphics area, then pick an empty space of the graphics area, you are brought back to the previous location in the Feature Manager. This behaves this way no matter where your Feature Manager starts from. Assembly Expert has been enhanced as well. Rebuild time is now reported in seconds as opposed to milliseconds, and we now list the number of hidden components, virtual components, envelope components, and the number of flexible subassembly mates. This can be important when troubleshooting assembly performance issues. Finally, the View Mates tool has been enhanced to now include features as well as components. Now I can see any mates that may be referencing a plane, axis, origin, or any reference geometry. This also works for sketches and curves, which makes it easy to see how the assembly is constructed. But it doesn't stop there. Let me hide this bushing to get access to the hole in the subframe, and you can see that I can view mates on this feature. In fact, I can view mates on any face or surface as well. This is very beneficial, especially when making changes to components of an assembly. You'll now be able to see which other components will be affected.
SolidWorks 2014 provides us with greater consistency in how we do patterning at the assembly and part level. We now have all of the same capabilities at the assembly level that we had at the part, such as sketch-driven pattern, curve-driven pattern, and also we have pattern-driven pattern. Let's take a look at a couple of those. With the curve-driven pattern, we simply select the sketch that we want to use to drive our pattern, and in this instance we're completing our chain links. So we're going to pick the segments that we want to pattern, control the tangency, and then we come in and we can specify how many instances and the spacing. And just like that, we can quickly and efficiently complete our patterning. We've added some other enhancements with patterns, and that's relating to visualization of the seed as well as the instances of the pattern. So now when we click on any of the patterns, we have a different color for the seed, which makes it very identifiable where the seed is, as well as the instances. Also at the part level, we've improved naming of the patterns. With the pattern-driven pattern, again, it's a very straightforward process. Pick the items we want to pattern. In this case, we're going to pattern the carrier to complete our chain system. And then to use an existing pattern, we're going to pick this block here. And with just a couple of clicks, you can see we've very quickly been able to pattern our system, and again reduce the amount of effort we have to do in setting up individual patterns by reusing what we've already done. So that's actually quite a bit of a time saver for us. Another area where we've made enhancements with patterns is with regards to multi-body features in part level. Normally we have a pattern such as a cut extrude like this, and we change its variables such that it's going to create multiple bodies. We now have the ability to pick and choose the bodies that we want to keep of all the items. So it gives us great flexibility in what we want to do for the intent of the pattern, which gives us greater control and more flexibility than we had before. So some great enhancements here for dealing with patterning at the assembly level, as well as improving our multi-body capabilities at the part level.
SolidWorks 2014 improves the methods that we use to mate assemblies together and adds new capabilities to complete the job faster. Let's take a look. In SolidWorks 2013, when I used the alt-drag method of smart mating, the component to be mated tried to mate itself into any potential reference that it crossed, such as this bracket jumping into every hole. This behavior was annoying, so in SolidWorks 2014, a new option has been added to control the Smart Mate sensitivity. I'll set it to slow so you can see how it works. Now, when I Alt-drag the bracket over the holes, it doesn't try to mate itself into every hole it crosses. Only when I pause will it attempt to Smart Mate to the hole. Another method of smart mating has been around for years, but it was not readily accessible. It was inside of the Move command. With this method, you double-click a reference, then click the corresponding reference, and SolidWorks presents the Mate toolbar. You also notice that now there's an option to lock rotation when adding concentric mates, which can be beneficial when assembling screws. One of the benefits of this Smart Mate method is that you can rotate the model while selecting mate references, which cannot be done with the Alt-drag method. This method of smart mating is no longer hidden. It now has its own button that can be customized to a toolbar or to your shortcut bar. We need to add another mate to control the rotation of the bracket. For this, we use the standard mating technique. Notice that now, when I add a mate between these two edges, SolidWorks now defaults to a parallel mate, as opposed to a coincident mate with a warning that it would overdefine the assembly. Also notice that now the Property Manager now has a push pin to be consistent with other Property Managers. The checkmark dismisses the Property Manager if the pin is not pushed. When mating an axis to a cylinder, the mate type is now automatically defaulted to a cylindrical as opposed to a coincident mate as in 2013. Much more logical. As if that wasn't a fast enough way to mate components together, SolidWorks 2014 introduces Quick Mates. No command needs to be executed. Just make your selections and a Quick Mate toolbar appears, and you select your mate. 3 picks and you're done. This is fast and kind of fun. Let's keep going. And to fully define these nuts, the new lock rotation capability is just a right click away on any mate selection. It's never been easier to put your assemblies together than with SolidWorks 2014. Mating spheres in SolidWorks 2014 gets much easier. In SolidWorks 2013, we are able to mate spheres tangent to spheres, planes, cylinders, and cones such as the surface generated by the chamfer. We're also able to mate a sphere concentric to another spherical surface. But we were not able to mate a sphere to non-planar entities or edges or sketches. These limitations were removed for SolidWorks 2014. Now we can mate spheres tangent to edges, such as this parabola, or tangent to non-planar faces, such as this one, created between a conic and an ellipse, or to a toroidal surface, or to this spool shape. I can also mate a sphere tangent to any one of these sketch entities, such as this 3D spline. As I said earlier, mating spheres in SolidWorks 2014 gets much easier. SolidWorks 2014 introduces a new mate called a slot mate. The only requirements for the slot mate is that the sides be parallel for straight slots and concentric for radial slots, and that the radii are equal. Select the cylindrical face and any face on the slot, and under mechanical mates, choose the slot mate. Constraints in the slot are free, centered in the slot, distance along slot, and percent along slot. I'll set this one to free and hit OK. Doing so allows me to move the screw along the slot from one end to another. Let's change this mate and choose centered in the slot. This locks the screw to the center of the slot, but allows it to rotate. Distance and percent along slot are pretty straightforward, and I can flip the side from which they are dimensioned. Other items that can be mated to a slot are holes, such as the bore of this washer. And I can also mate an axis to a slot as well. But it doesn't stop there. I can mate slots to slots. and you can see that I have full range of motion through both slots. Radial slots can be mated to radial slots. And when I unhide the screw mated to the nearest slot, you can see how it moves. Slots on cylindrical surfaces can also be mated, such as to this screw. Slots that are not supported are those which have one or more square ends, slots that contain straight and curved sections, as well as slots that break over the edge of the part.
SolidWorks Plastic 2014 contains many new enhancements that will make it easier to analyze and optimize plastic injection molding parts, even for new users. The new Getting Started wizard, for example, walks you through the setup process and provides additional information to help you clearly understand every single step of the process. Armed with this knowledge, you can start meshing this plastic cover using a shell mesh with automatic refinement. Each step is clearly identified and marked when completed. Next, the plastic material can be selected in just a click. And all the field settings and advanced parameters are easily accessible because they have all been grouped in one place and organized in different tabs, with only the most important one, such as injection pressure limit or mold temperature, prominently displayed. Finally, the injection location is defined and the injection molding analysis can be run. With this simple and streamlined user interface, new users can be sure to get it right the first time and be more productive. SolidWorks Plastic 2014 also includes a new runner design wizard. After selecting the layout, simple or complex runner systems are quickly designed by picking the injection locations. There's no more time wasted having to manually drawing them using sketch lines, and you can easily customize the length or start and end diameters of any section of the sprue, runner, or gate. Now, let's switch to another configuration to review the results. In addition to numerous result plots that allow you to investigate your model and better understand the injection molding process, the new Results Advisor provides you with comprehensive information about each result plot, any potential manufacturing problems, and result-specific advice to resolve any issues. This makes it simple, even for novice plastic part designers, to fix and optimize their parts for manufacturability. And with a traffic light at the top, you can see in a glance if the part you created can be molded. SolidWorks Plastics not only helps you check for manufacturing defects up front. New export capabilities let you take into account the in-mold residual stresses when testing product performance in SolidWorks Simulation 2014. After exporting the results, you can turn on SolidWorks Simulation and create a new analysis to use the plastic results. In addition to other forces, pressures, and loads on the molded plastic cover, the in-mold residual stresses are easily accounted for in this nonlinear analysis for increased accuracy, and to avoid having to create or redefine materials, you can simply decide to include the material properties from SolidWorks Plastics. SolidWorks 2014 offers a variety of new tools, wizards, and export capabilities, so you get more done in less time while ensuring your products meet your design and manufacturability requirements.
SolidWorks 2014 provides a far more streamlined process when integrating SolidWorks geometry into CircuitWorks. We're now prompted with an export wizard, which is a very simple step-by-step process where we just click through selections to define what we want to do for setting up our board, along with any holes or keep out areas. And with just a few clicks, we can quickly generate our model inside CircuitWorks. Now, CircuitWorks itself has a lot of enhancements to the interface. For example, we can look at the properties window and we can do multiple selects now in the tree, and we now have options to filter out items, disassociate those from the model with a right click, zoom to fit, and so on. So there's a lot of convenience there within the interface. The middle mouse button now allows us to zoom in and out with the mouse wheel, pan and rotate, or double click to fit the view. Similarly, in the library we now have a consistent look and feel, and they've added a wizard to the library, so if you want to add components, it'll take you through a step-by-step process to pick the files and then add them to the system. So again, trying to streamline the process and make it a lot easier to work with, and that's going to mean that you can get your job done in a lot shorter time frame. Now, something else they've added to SolidWorks in 2014 is additional thermal properties. We can see over here we now have material density, specific heat, conductivity, heat generation rate, and resistivity. This is very valuable because this can come from IDF files with the components, so in your electrical designs, into SolidWorks, and then these are also supported in SolidWorks Flow Simulation. So not only do we have that extra information in SolidWorks, we can take advantage of it directly in our analysis. The benefit of that is going to be automating the process of entering the data so that we don't have to manually type it in again. So in SolidWorks Flow Simulation, we can scan all of the geometry in our model, and then it will automatically identify additional materials or any thermal properties. So we see our thermal properties as well as our heat input for all the items. So as you can imagine, that's a great time saver for speeding up the process of setting up our model, and it avoids the potential for introducing errors through entering the wrong values. And we can see here there's quite a substantial number of heat sources generated, as well as material properties. And again, it's going to streamline everything we need to do for verifying the heating and cooling of our designs. Something else that we've added in SolidWorks Flow Simulation for 2014 is when exporting to eDrawings, so you can share your results for other people to look at, we now support multiple result types in eDrawings. So we can come and look at our model and see all the different result types, which makes it very easy to compare a lot of different properties. And we can even toggle those on and off, whether we don't want to see our section plot or our flow results. So again, great improvements there in SolidWorks integration with analysis as well as electrical design.
SolidWorks 2014 streamlines common design workflows with innovating visualization tools and an improved user interface. The overall user interface, including the Property Manager, Command Manager, and Task Span, to name a few, now feature a clean and modern look and feel for added clarity. In addition, the selection icons have been modified across the entire software to use a different color scheme more suitable for colorblind people. This way, they can clearly understand the entities that need to be selected for each feature if detailed explanations are not available. When working on complex parts and mechanisms to create, for example, design variation, the same features are often modified over and over. To quickly modify your design and help you collaborate more effectively, SolidWorks 2014 has added a new history folder. By default, the last 10 edited features are listed, but like everything else in SolidWorks, this number can be adjusted to your liking. And unlike the favorite folder that requires items to be added manually, the new history folder automatically keeps track of the features you recently modified, so you don't need to go through the entire feature list to refine your design. Once satisfied with this new iteration, you can save a copy of your assembly. However, to avoid time-consuming mistakes, you now have the option to save a copy and directly open the new file to carry out your work. You can also decide to include all the reference components, parts and subassemblies in the same folder or a specific folder, and whether or not to add a prefix or suffix. Switching back to the full assembly, it's easy to make the external covering transparent using a display state. With a new order-independent transparency that leverages the latest graphic card technology, you get faster, nicer, and more accurate transparency rendering. This new technique also provides better results with each object properly displayed at the correct depth, even when rotating your model while rendering multiple overlapping transparent bodies. But to dive even more into your design, you often need to use the Section View tool. Luckily, in SolidWorks 2014, the new Selective Section tool makes it easier to examine your complex assemblies. You can now simply select which components or bodies to section, and everything else will remain untouched. You can visualize internal details and keep parts of the external covering to perfectly understand how everything is assembled. If it's a large assembly, you can also leverage the groundbreaking technology behind Large Design Review to instantly section the model. SolidWorks 2014 delivers superior visualization capabilities with a new and enhanced user interface to help you design better products and improve product quality.
Let's take a look at a few of the great enhancements in SolidWorks Simulation in 2014. Anyone who's worked with fasteners before realizes it can take quite a bit of time to set those up in simulation. This is a thing of the past in 2014, where we now can automatically detect toolbox fasteners and map those across to simulation connectors. It's a very quick process and saves a huge amount of time in the setup of a model, but more importantly, it also ensures you have accurate information about the connector, such as the size of the fastener, the type, material, strength data, and even the preload requirements. So that's a great improvement that we have in 2014. We've also made some great improvements in the interface to make it a lot more efficient to interact with the model and to make changes. Now through the legend you can right click and select different stress components. Maybe you want to look at principal stresses or change it to different result type. So you can see we've got quite a lot of detail here on what we can view. We can even animate the model from this position. Also, if we want to modify any of the settings, we now have all of our options in one property manager. So we can adjust the definition, any of the chart settings such as showing the max value, or the settings where we might want to show the mesh on the model and so on. So everything really is at your fingertips. It's also very easy to come in here and quickly adjust the scale of the legend to suit whatever needs you have. So it's much more convenient than previously. We also have some great enhancements in 2D simplification. One of the things we've added is improved ability to look at contact situations, and one of the common results people look for is the contact pressure. This is now supported in 2D simplification as either a plot or as vectors, which really enhances our ability to understand where the load transfer is occurring and gain greater insight into what if we need to make changes. Now, something else that's been improved in 2014 is our ability to apply materials. We now have a connectivity to the materiality website, which enables us to access a much more wider section of advanced material properties. When the site comes up, all you do is specify the type of study you're interested in. In this case, I'm going to do a nonlinear. So we pick the material model that we're interested in, such as plasticity, von Mises, or hyperelastic. Then we choose whether we want a subclass of materials, and then any further subclasses. So for example, maybe we're interested in plastics, select locate materials, and materiality will come back with a very extensive list of material properties. Tooltips give us more information about these, but if we want, we can pick particular items, for example Delrin, and then it will bring up the different results. For example, here we have different thermal result properties. When we do the start conversion, it will then extract the data into an appropriate format for us. We can even look at the data visually, so we can see here the stress strain curve. And all we have to do is select download, and then we'll save it to a SolidWorks material file, which we can then link in, or if we put it in our library, so that we can access it through our environment here. So we've got a lot more powerful material properties available now for advanced materials in nonlinear realm primarily, but it saves you having to go and research that yourself. We also have some great enhancements on the contacts visualization front. When you select on the connectors branch now, we have a new contact visualization plot, which is a powerful tool for helping us review our model to determine how we've set it up. And different contact types will actually come back in different colors. So red is for bonded. You can even pick specific bodies that you want to check contacts between as well. In this instance, we can clearly see that there's no contact defined between the vertical face on this side wall and the back face. So this is a great debugging tool to help us identify problems, as well as to see what we've already done and what else has to be set up for the model. Another area that we've improved is with visualization of results for symmetric models. Here we have a symmetry plane for this model, and if we just hide the symbols, when we do the edit definition now, under advanced options we can now display symmetric results, which helps for conveying result information to other people in the company that may not be as familiar with simulation, and where if they see only a portion of it, it's a bit harder for them to interpret the results. So that's a very powerful tool. But there's also another very valuable tool for reviewing results, and that is the new compare results capability, which includes support now for comparing across configurations. The interface is very similar to what it was before, but now it will actually load each individual configuration, enable us to quickly look in and review the results on those designs to help us again zero in on which design we want to focus on to further develop as we progress with our design cycle. So some very powerful capabilities in SolidWorks simulation. We've also got some enhancements for performance. In the simulation settings now, you can control when results get loaded. So if you are working on a lot of SolidWorks features, you can now turn off loading simulation results when the model is open to delay that extra overhead. So this means that you can have simulation out in active and it won't cause overhead when you're working on SolidWorks operations. Another great feature that we've added for people who work with very large model designs is there's a new large problem direct sparse solver. This solver is tailored to models that are dealing with millions of degrees of freedom. If it's set to automatic, SolidWorks simulation will automatically determine which solver it needs to use for you, so you don't have to worry about it. One other benefit of the large problem direct sparse solver is that it has very good support for multi-core, and so not only can it solve very large problems in terms of 5 million, 10 million degrees of freedom, it can also do it a lot quicker than previously because of the multi-core support. So a lot of great capabilities there that we've seen in SolidWorks simulation.
SolidWorks 2014 includes several new enhancements to help you showcase your models and bring your 3D geometry to life. You can now export your model, including motion studies, to an LXO file to be used with Modo, like Synology One non-rendering software, opening new possibilities. The current view can also be saved directly as a PNG file to be inserted into your PowerPoints or reports. They are even perfect for brochures thanks to multiple options that let you, for example, remove the background or increase the DPI dot per pixels. To better showcase your models, a realistic backdrop can be used. SolidWorks 2014 features new scenes and landscape that let you convey your ideas more clearly. These realistic environments are quickly accessible from the same convenient location and are grouped by type. They can also be stretched to accommodate any screen resolution. Additionally, when switching to the spherical environment, you can now flatten the floor for added realism and customize the environment size and horizon height. This way, your model doesn't appear to float. This pergola now rests on the ground like it's supposed to, with realistic shadows and reflections. PhotoView 360 has not been left behind either. SolidWorks 2014 integrates even more effects out of the box. A new cartoon option, for example, is available in the Property Manager and allows you to create cartoon renderings to make this model appear hand-drawn. Options such as line thickness and line color can also be modified to match your needs. Then, it's just a matter of generating the final rendering to explore new ways to promote your product. This, amongst other effects and post-processing capabilities offered by PhotoView 360, greatly limits the need to rely on a third-party software to create marketing collaterals. Some products, however, are meant to be used outside. A new type of light called sunlight can be easily set up and provides a realistic representation of sunlight based on a few parameters. After setting up the north direction with respect to the model, the geographic location or latitude and longitude can be defined, as well as the time zone, date, and time to simulate. The sun position, shadow, and lighting instantly update to reflect the changes. This is invaluable to evaluate how your design will look in different environments using life conditions. You can even create a solar axis study using the SolidWorks animator to simulate the movement of the sun as it passes over your model. Two types of solar axis studies are available. You can decide to display the path of the sun on a fixed and specific date across a range of time, or at a specific time across a range of dates. You can even specify a time range or simply select from sunrise to sunset. After the calculations are done, you can animate the solar axis study directly within SolidWorks. And with network rendering, now available for animations as well, you can quickly generate high-resolution, lifelike animations of this solar study. With best-in-class rendering technology and innovative tools, SolidWorks helps you better leverage your existing work to create more immersive experiences or to sell your design ideas to potential customers. eDrawings has always been the easiest way to share your documents. With several new enhancements and the improved support of simulation results and content from SolidWorks Electrical, it's now also the best and most effective way to collaborate with all the people involved in the development of a project, regardless of their CAD experience. Exploded views, for example, are invaluable for understanding mechanisms and to create detailed assembly or repair instructions. eDrawing 2014 can now view and animate exploded views with rotation saved in assembly files created with SolidWorks 2014, so you can easily show all the steps required to remove or put in place this piston, including the loosening of the fasteners. Multiple SolidWorks flow simulation plots can also be exported in a single eDrawing file, which greatly simplify collaboration. You can effortlessly share all your results with your coworkers. No more time wasted sending multiple emails or looking for specific results, since everything is included in the same file. Just hide or show the different result plots depending on your needs. Simulation results are available as well, and for added clarity, eDrawing 2014 enables you to display the results of your analysis on the full 3D model even if you simplify the simulation by using symmetries. No matter if you are interested in the stress, displacement, or factor of safety, eDrawings lets you explore the results on the full 3D geometry. To be able to rapidly visualize all the dimensions and tolerances of a part, wherever you are, DIM Expert dimensions are supported and fully available in eDrawings. You can share all the details and manufacturing information of this component and its different configuration to any of the project's stakeholders. This makes it easy to request quotes from partners without having to create drawings or simply to allow quality technicians to control manufactured parts. Electrical engineers and technicians will also enjoy having direct access to their entire electrical project and schematic. In fact, sharing key information between different departments of an organization has never been easier. In addition, the multi-platform desktop and mobile applications ensures that every employee is within reach, from the technician on the shop floor that needs to quickly troubleshoot an installation by instantly accessing critical information and diagrams on his mobile device, to engineers and sales representatives in the field. Finally, you can now view models from 3D Content Central directly from your mobile device. You can leverage the SolidWorks famous catalog of components used by thousands of professionals and containing millions of 2D and 3D models to find the part you need for your next project in no time. Using the tablet browser, you can go through different categories or search for the right component, choose the appropriate version, and open it in eDrawing straight away. You can rotate the part, look at the different configurations, section, or measure it. No matter if you're using a computer or a mobile device, eDrawing 2014 features many new enhancements to ensure you clearly communicate your ideas and collaborate more efficiently to improve product quality.